Hello, thank you for inviting us to this workshop. Today we will talk about using authentic exoplanet data to promote active learning of physics and mathematics in school. My name is Carla Hernandez, and this work is elaborated in collaboration with Fernando Alarcón, Ignacia Benito, Irma Fuentes, and Sebastián Pérez from Universidad de Santiago de Chile. In 2021, the Center for Interdisciplinary Research in Astrophysics and Space Science was created. Among the different lines of research that are developed, the astronomy education research and outreach was created in order to promote astronomy in formal and non-formal educational contexts. Although we have developed many outreach activities, the main challenge we set ourselves was to get closer to the schools. Chile is a privileged geographical place for astronomical observations, being one of the most relevant areas of development in the country. We believe that frontier astrophysics provides an attractive and challenging scientific context to engage students in their learning and develop important skills for the future. However, astronomy content in a school program is scarce and is teacher training on the subject. This situation represents an obstacle for students to learn more about astronomy and especially about the research developed in Chile. Furthermore, there are few spaces where teachers and scientists can collaborate and exchange knowledge. To address this problem, we decided to create a working team at the research center with the participation of high school science teachers in order to co-design activities based on the use of authentic data from different lines of research in astrophysics.
Last year, our team was awarded the first project to bring the activities into the classroom, funded by the European Southern Observatory. To develop this project, we started by choosing the topics that are lines of research in astrophysics at CIRAS. As a second step, we analyzed the school curriculum to identify those learning objectives in which an astronomy-related activity can be incorporated. Secondary school in Chile refers to the stage between 14 and 18 years old. Our team started to meet periodically, every 2 weeks, in order to create activities. Once the activities were designed, we applied them in 2 different courses during the second half of 2021, and with the results, we improved the design of the activities. Although the center is developing several astronomical lines of research, the educational proposals are currently focused on only 2 main topics, exoplanets and pulsars. Several learning objectives that are mandatory in the Chilean curriculum were chosen for the subjects of physics and mathematics, and they are related to populations in double entry tables and scatter plot, describe and compare different cosmic structures, explained by means of Kepler and Newton laws of universal gravitation and the formation and dynamics of natural cosmic structures. Each activity includes a work guideline for the student and astronomical data set with Excel tables, as well as didactic orientation for the teacher. The activities designed by our team were implemented in schools of the participation of teachers, 27 students in physics course and 70 in the mathematics course participated for the first secondary level and 32 students in the physics course for second secondary level.
As an introductory activity related to the use of real exoplanet data, we begin the educational sequence with an exploratory activity. Using the free NASA Eyes on Exoplanet website, students are invited to search stars previously selected by us with the purpose of introducing them to a wide sample of stars of different spectral types and different types of exoplanets. In second activity, students are asked to record information comparing the host star to our sun, as well as the exoplanet size compared to Earth or Jupiter. They can also compare the habitable zone of our solar system and the extrasolar system, identifying a possible relationship between the type of star and the distance at which its habitable zone is located. In order to recognize exoplanet populations, the students are asked to plot the masses of solar system planets as a function of distance from the sun, and then the same procedure for mass versus distance from the host star for a set of over 800 exoplanet data. The goal of the activity is for students to be able to recognize different exoplanet population based on similarities to the location of solar system planets on the plot. In this activity, they can also establish a relationship between the type of exoplanet and the detection method used to discover them. It is also important to mention that another activity was applied in order to test Kepler's third law with data from extrasolar systems. A student plotted this relationship for solar system and extrasolar system planets, and they compared the slope values to define the difference between the two proportionality constant and discuss their difference. All data used in our exoplanet and pulsar activity were obtained from open access online catalog created and used by professional astronomers. They were modified to an Excel version to facilitate their use from teachers and students in schools.
Well, with the application of the activities, we have obtained different results that go beyond the learn of the contents. With the exploration activities, we were able to identify some of the students' beliefs and preconceptions related to astronomy. For example, about the factors that determine the habitable zone of a planetary system. With the development of the activities, students have the opportunity to contrast this type of beliefs. Students learn that the variables on which the habitable zone may depend on the hot star and the exoplanet characteristics. We asked a student if they believe that the habitable zone may change over time, and responses were very varied and very interesting. We consider this result to be very valuable for teachers because they can create new activities related to these topics, or proposing research projects and working with other disciplines. Regarding the students' opinions on the work carried out, these have been very favorable. They mostly use adjectives such as fun, good, and interesting to describe the work done in class. In the last implementation done with the enhanced activities, we asked students if they thought using authentic data allowed them to learn more about how science done, and 100% said yes. We were also able to identify favorable change in student perception of science and astronomy. Most of the students expressed a favorable change in their perception, since they could see that mathematics and physics contents are used to analyze astronomical data. At the end of the activity, students were encouraged to formulate questions for the astronomers based on the work done in class. We were able to identify questions formulated in 4 broad categories: nature of science, scientific knowledge, scientific activity, and scientific career. After these results, we are scheduling an activity where students can directly ask the question to the astronomers of our center.
As main conclusions so far, we believe that it is possible to bridge the gap between research and the classroom. It requires collaborative work between researchers and teachers based on horizontality. Our results show that the scope of these activities is extensive. Beyond learning astronomy, physics, or mathematics, students manage to learn about science and become interested in scientific work and the people who do it. As limitations, access to technology is still a problem and a barrier in many countries. However, in the teacher guidelines, we propose alternatives. We will also conduct a free training workshop for teachers in Chile who want to implement these proposals in their classroom with the support of the recently adjudicated teacher training pilot program. We were Also assigning hours of astronomical observation at Las Cumbres Observatory to obtain light curves of the NOAA eruptions in order to develop activities to teach exponential and logarithmic functions. And very recently, we received the news of support to continue with our project. We will work with an amateur observatory in Chile to obtain real data of southern star spectra. In this way, we will add a chemistry teacher to create new activities. To conclude this presentation, we invite you to visit our website where the activities will soon be accessible for free download in Spanish. Thank you so much for this space to share with you our project.